Hey everyone, welcome to Magnitude. This is Moinak Dasgupta and today we have came to the next part of the semiconductor series, and today we are going to discuss about the PN junction, the barrier potential, the depletion region, and at the last we will also discuss what is biasing. In the last video, we have discussed what is drift current, what is diffusion current. So if you missed that video, then please watch that video. I will give the link in the description box. And if you are new to our channel, then please subscribe to our channel and hit the bell button to get the latest updates of our channel. So not wasting much time, let's begin. Now, what is PN junction? So we know there are two types of semiconductor material. One is P-type, another one is N-type. So in case of P-type material, we know that holes are the majority charge carriers. So I represent these things as holes. And in case of N-type material, the majority charge carrier are the electrons. So I name them as electrons. So what happened when this p-type material and the n-type material are connected together, then they are known as PN junction. So let us draw how the P and N are connected. So when they are connected, they looks like this. So what happened? A junction is created between the p-type and the n-type material. So next what will happen? We know there are free electrons in the n-type material and the positively charged holes are there in the p-type material. So what happened? The electron present in the junction part and the holes present in the junction part of the p-type and the n-type, they will be get attracted towards each other. So what happened when they get attracted towards each other? The electron from the n-type will jump to the p-type and they actually move from n-type to p-type due to the force of attraction. Then what will happen? They will create a negative ion on the p side and some positive ion on the n side in the place of the junction. So how it looks? It looks like this. So what will happen? The positive ions will be created on the n side and the negative ions will be created on the p side. How it happens? When the electron from the n side travels to the p side, then the electrons actually leave some positive part on the n side. Means when an electron comes from one side to another side, the vacancy of electron is created, and we know the vacancy of electron is a positive. So a positive part is created here, and this type of ions are known as acceptor impurity ions, and this type of ions are known as donor impurity ions. So in this way a PN junction is created where the p-type and the n-type material are connected together, and ions are immovable ions of donor impurity ions and acceptor impurity ions are created, and this is known as PN junction. Now what is barrier potential? So this barrier potential is a very important concept, and the barrier potential is also known as barrier voltage. So what is this? The PN junction is created till now. Now after the creation of PN junction, we can see that the negative ions are created and the positive ions are also created. So now the free electrons cannot travel to the p side. Why? Because the negative free electrons will be repulsed by the negative ions present at the junction of the p side. Similarly, the positively charged holes will cannot travel to the n side just because the positive ions present at the junction of the n type will repulse them. So what happened? This one is known as a junction. This one is known as a junction, and this prevents the flow of majority charge carriers from one side to the another side. So they are creating a barrier between the p side and the n side. So this is known as the barrier potential, and the voltage or the potential difference between the barrier of the P side and the N side is known as barrier potential. But have you noticed one thing? The barrier potential always opposes the majority charge carriers to cross the junction. But if due to some reason on the P side some free electrons are created, or on the N side some holes are created, then they will be attracted towards the junction due to these negative ions, and similarly for N type due to these positive ions, and they will cross the junction. So the barrier potential opposes the majority charge carriers but does not oppose the minority charge carriers. So what is depletion region? So when a PN junction is connected, we can observe one thing, that is a small region or a small layer is created in the junction part, and this region or layer is known as depletion region. So in other words, we can also say that depletion region is that layer or region which is free of any kind of majority or minority charge carriers. Means in this region you will never find any kind of charge carriers. We will only have immovable ions, means these ions cannot move from one side to another. So this one is known as depletion region. In our next videos or in our upcoming lectures, we will get to know that how this depletion region or depletion layer width can be changed. Means we can change the width of this depletion region to a higher or to a lower form. And this region does not allow the current to flow through it. So if this region increases, then definitely no current will flow through it, and if this region decreases to 0, then only the current flow through it. So if the both side of P type and the N type materials are equally doped, then the depletion region in the both the side will be equal. But if on the one side the impurity is highly doped, then the opposite side the depletion region width will be greater. What I mean to say, I want to say that if in P side, suppose in P side the impurity is higher, means we have added some extra impurity in the P type, then what will happen? Then the depletion region will increase in the N side. So the depletion width will be increased, and in the N side it will be a greater width as compared to the P side. So this is all about the depletion region, the barrier potential and the PN junction. So now the question comes that what is the formula to find the barrier potential, or how we can find the barrier potential? Firstly, I would like to say the barrier potential is same as built-in potential or barrier voltage. All these terms are same. So how to find that one? We represent barrier potential as VB. So VB is VB. This term is known as barrier potential. So how to find this one? VB equals to VT into ln Na Nd by Ni square. I will tell all of this term individually. So firstly, what is Vt? Vt means Kt by E. So what is Kt and E? K equal to 1.38066 into 10 to the power minus 3 joule per Kelvin. So you all know that this is Boltzmann constant. And what is T? T is the temperature in Kelvin. So if T dash be the temperature in Celsius, then we can plus 273 to it, and to find the temperature in Kelvin, that is the absolute temperature, and E is the charge of the electron. So we can find Vt. It will be a constant term if we know the temperature. Okay, so Vt can be found from here. So what is Na? Na is the acceptor concentration, and what is Nd? Nd is the donor concentration. And we all know what is Ni. Ni is the intrinsic carrier concentration. So in this way we can find the barrier potential of any kind of semiconductor material. Means the barrier potential of any PN junction. So in case of room temperature, for silicon semiconductor, we can say the barrier potential will be 0.7 volt, and for germanium it will be 0.3 volt. These two will be only in case of room temperature. So in case of room temperature, the barrier potential for silicon and germanium is 0.7 volt and 0.3 volt. So what is biasing? Till now, whenever we have drawn any PN junction, you cannot find that we have added any kind of battery or any power source. So what happened till now? Till now, whenever you have drawn a PN junction, it looks like this. There is P and here is N. So after this, no external battery is connected. So in case of biasing, we will connect some external power source to this PN junction. It may be on the P type or it may be on the N side. Means the positive terminal might be on the P type or it might be on the N type. It depends on which kind of biasing we are doing. So biasing actually means the connection of any external power source with the PN junction is known as biasing. So we have connected our power source with it. So up to this in this video. So in the next video we are going to talk about the forward biasing, reverse biasing, VI characteristics and many more topics. So if you like our video, then don't forget to hit the like button and also share this video with others. So if you have any doubts, don't forget to share those in the comment section. And signing off for now. See you soon in the next video.